Hello, my name is Ike McKinley, and this is NOS 220, Linux System Administration. This video will cover the basics of Linux processes and how they can be managed by the administrator. We'll be looking at just what a process is, and some of its attributes, how to list, stop, and start processes, how processes communicate, and how users manage their own processes via job control and other tools. Processes are fundamental to how Linux operates, so hopefully, once you understand them, you'll have a much clearer idea of the system in general. So, what is a process? In its simplest terms, a process is a single task that the system is being asked to perform. It could be an application, such as a web browser, a command line shell, or a system daemon that runs in the background. Some applications, especially server applications, run multiple processes. Others have only a single process. But anything that your system does must have a process associated with it. The very first thing that the system does after the bootloader has loaded the kernel is load the Init process. This is a special process that is responsible for initializing the system and starting up all the other processes. Each process has a unique process ID, which identifies the process to the kernel. The Init process has the process ID of 1, for example. The system also tracks other information about each process, such as the amount of memory allocated to it, how much processor time it's currently using, what command started the process, and how long it's been running. A process can start another process. When this happens, the second process is said to be the child, and the starter process is called the parent. This is also tracked by the kernel. Also, each process is an owner. For most system processes, this is usually the root user. For processes that are started by a given user, that user will own the process. Finally, there are a number of variables, known as environment variables, that are tracked for each process. All of this information can be seen using the process listing tools, PS and top. Of the two, PS is the simpler. It provides a snapshot of currently running processes in order of process ID. In order to get a listing of all processes, the AX switches need to be used, and AUX should be used if owner information is desired. In addition, you can use the F switch to get a graphical representation of the parent-child relationships between processes. While PS is an extremely useful tool, the information is static, so multiple PS commands are necessary to see the effects of user actions. The same information can be seen dynamically using the top command. While not quite as flexible as PS, top updates once every second, although this interval can be changed. In addition, top sorts, by default, that is, processes by the amount of CPU time that they use. So it gives you an excellent idea of what processes are consuming the most resources and how that changes over a certain period of time. The only problem with top is that it's limited to a single screen's worth of information. Any processes that don't fit on a screen simply are not shown. Still, top can be extremely useful when dealing with a bogged down or non-responsive system. Another basic aspect of process that often gets overlooked is the fact that processes need to communicate with one another. In Linux, this is handled via IPC, or inter-process communications. The IPC system consists of a number of flags or semaphores that each process uses to alert other processes that communication is needed. However, semaphores are limited in number, and a crashed or hung process will sometimes fail to release the semaphores that it's using. Thus, the use of the IPCS command, which lets you see what processes are using semaphores, and the IPCRM command, which removes certain semaphores, such as you might get from having a hung process. Both of these can be crucial to maintaining a system without having to reboot it. Earlier, we mentioned that many processes have owners. Any user can start a process, and when they do, the process becomes an active job. Jobs can be listed using the jobs-L command, and this can be a useful way for users to keep track of what they've been doing, especially in a command line environment. Users can place jobs in the background with the BG command and the job number, or make it active with the FG command. Users can also control their process directly using the kill command, which would send signals directly to the process to either terminate cleanly, restart, or terminate immediately. So, this lesson we looked at the Linux processes and how to manage them. We examined the attributes of a process, how to gather information about processes using PS and top, how to manage processes via job control, and also the kill command. Next, we'll be looking at Linux file systems and how they function.